Welcome back everyone after lunch. Hopefully everyone had a nice feed and was able to walk around some of the vendor booths, and so thank you again to the lovely sponsors here. Next up we have Pieter Danhieux from Secure Code Warrior talking about software is your colleague, a new perspective for developers to reduce the attack surface. So Pieter Danhieux is the CEO of Secure Code Warrior, a global security company that makes software development better and more secure. In 2016, he was number 80 on the list of coolest tech people in Australia from Business Insider and awarded Cybersecurity Professional of the Year from ASA. So can we give a very warm welcome to Mr. Pieter Danhieux from Secure Code Warrior.
Hey guys, good afternoon, and thank you very much for spending your after lunch nap with me. I don't know how it sounds, but like the coolest person in 2016, that's like 6 years ago. That's not relevant anymore, I think. I'm not cool anymore, obviously. But thank you for kind of making the time and kind of spending it with me. Now, a little bit of background about myself. Probably you've seen on my name, I didn't grow up here. Early 2000, I was a security geek. I lived in Belgium. And I was very much involved into the hacking community, starting a Brucon, doing capture the flag, so I was really in a lot of technical stuff. Now, fast forward 22 years, and now I spend my time in spreadsheets and metrics and Excels and salaries and hiring and all that kind of stuff, running a company, which is probably the hardest thing that I've done in my life, but you can kind of see the journey I've kind of made from Belgium to here in Australia. Now, in between, I've written a lot of bad code, I've seen a lot of bad code, and it's one of the problems that I actually want to help the world with, is getting rid of all of that bad code. Now, for today, I don't know, I was here last year as well, exactly on a Friday after lunch again, but something dramatically changed in about 12 months' time. Now, what actually changed is that after about 20 years, we finally have a new winner. And I'm going to ask for a little round of applause for this, because the new winner is we basically got rid of injection attacks from the number one in OWASP top 10, and it got defeated by, yes, broken access control. Now, this is unique, right? Because 20 years long, the first time that OWASP top 10 was released in 2003, injection attacks and untrusted input validation has always been there as that sore eye problem. Last year it changed. Now, what we don't know, is it because there are less injection attacks that are being found, or there's just more broken access control basically popping up. But I do think that was an interesting change in history. Now you might say, well, broken access control, how difficult is it actually to solve, right? Because you authorize something, you check its identity, and you apply least privilege, problem solved. Well, you would think that is the case, but for a developer, it is often not the case. Because when you try to implement least privilege, right, and you're trying to restrict what a developer can do and basically put in user-based role access control, all that kind of stuff, it makes the life of a developer much, much harder. Because his testing becomes much more complex. They now need to run test cases specifically on user roles. So developers, what they often do is that they don't want to waste time and they don't want to waste efficiency, so they're going to start putting things in their code that kind of bypass the least privileges, that they can do all their testing with admin privileges just to kind of get through all the checks and so on. So that's one problem we have that, of course, is causing some issues with broken access control. The second thing that actually happened is that everybody is moving from a monolith piece of code to what is now microservices and APIs. Where if you had to implement access control in the past, it was pretty simple. You had a monolith, you put in your authorization, you put in your least privilege, problem's gone. But today, if you look at the average application, like there was a stat from an online banking application today, speaks with about 140 different APIs in the background, right? So an application today, whether it's a mobile, whether it's a site, whether it's an app on a television, or even things on a car, it basically talks with APIs to each other. And the problem is that if you want to implement access control and least privilege, you have to do that across every single API that is being used in that architecture. Now, It's most important in the APIs that are publicly exposed, but it's also important in APIs that are actually not publicly exposed and that are internal. So that's an added complexity, and that's one of the reasons why we find way more problems in APIs with broken access control. Now, normally I don't look at Gartner too much on what they're saying, but in this case, Gartner kind of said that, hey, the year 2020, or 2022, sorry, is going to be the year of API security vulnerabilities. And I actually agree with them, because we have so many APIs out there, and hackers and testers, they figure out now finally how to test these things and how to find these flaws. And there's some complexity with that, which I'll talk in a second. But the type of weaknesses that exists in the APIs is very often that APIs, they are too talkative. They give you way too much information than you actually need. Now, you don't see that because that's basically happening in the background. Your mobile app is talking to an API endpoint, and whatever objects are being transferred back and forwards, you don't really see that, right? Because it's never displayed. But it could be, and in a lot of cases, there's too much information being passed back and forward. So that's one of the problems you can have with APIs. Second one is around availability issues, that APIs, they're usually not behind WAFs. There aren't many WAFs that actually support APIs in a good way. And that means that, well, often these things are exposed to a whole bunch of new attacks like availability problems, denial of service, and all that kind of stuff. Now, I did put an example in around a very simple example that I stole from a website called API Mike. I didn't steal, I just used it, but which will show you what is possible with APIs. Now, this is a problem that will allow you to take down a system based on some very simple mistakes that have been made. Now, you can see on the green part, that is a legitimate request. Basically, it's an HTTP post request that goes to a search function, and in that search function, there is a body, and in that body, you can actually specify, hey, how many pages and how many results do you want to get back? Now, if you're on a search page or on a shopping cart page, you always have that on the button on the bottom that you can kind of select the page or see how many results you want to see. Well, that's exactly how this kind of works with the background, right? Now, what you can do is, of course, you can start manipulating some of those parameters. And you can say, well, instead of giving me a max return of 258, I actually want to have a max return of 9,000. So you're putting more load on the whole backend system and the API system. Now, do that a million times, and you can see that you're actually eating up resources in the background through those APIs, potentially taking down that system. Now, this is not far-fetched, because even we are a product company. That means we have engineers that are building products, and they're making the exact same mistakes as every single other engineer on this planet. And we had one of those problems with Secure Code Warrior last year, where we basically have leaderboards where you can see names of people when they're kind of playing the capture the flag games. But what happened is that when that leaderboard was being displayed, right, it was talking to the API background and saying, hey, give me the top 10 people that are currently leaders in that leaderboard. And the response came back with those top 10. Now, somebody figured out that you could change it to 1,000, you can change it to 10,000, you can change it to 1,000,000, and that certainly means we had 1,000,000 records going back and forwards between our APIs and so on, and the system actually went down from all the load. So it's a very simple mistake in an API can basically take down some of the applications and software that we're using. Now, a quick second example, exposing sensitive data, where this is an example of an API, and you can see on the left side, there is a request and a response. The request is basically showing you a profile with a user, and his user ID is that number there. And what happens if you normally send that request to that API, a response will come back and some data about that user will be displayed. And you can see the user ID gets put in the request, the response comes back, and some email address and personal information is being pushed back. Now, what could happen is that on the right-hand side, that is what an attacker would do. They would start manipulating some of those parameters. Now, if the API has been written in a bad way, and it needs to kind of get the user ID from somewhere. Now, it can get that out of the URL parameter, it can get that out of the cookie, and we need to make sure that that API is actually validating that you should have access or you can have access to that record. Now, of course, in this case, they didn't. So what happens is that the cookie might be valid and the user ID might be validated through the cookie. But the GET request, when you manipulate some of those parameters, you can actually get, again, sensitive information out there and basically enumerating data out of this API very easily. Now, what is currently saving us a little bit is that APIs are complex to test. It's not easy. There's no automated tools that can really do it in a good way. So low-hanging fruits are very difficult to find because you need to understand the complexity of that API, which is different in every API. Like the way on how you speak to the API, what parameters you need, when it's authorized, it is different for every single one of them. That means that when you do testing, you actually need to figure that out. And when you can figure out how the API works, only at that point in time you can start looking for some security flaws. And of course, because of that complexity, it is not always that easy for scanners and automated tools to find out the structure of the API and to find them problems. But tools are getting smarter, tools are getting better, and hackers are getting better, and more these problems will occur in those APIs. So developers, they need more guidance. They basically need to understand more about, well, how do I make sure I can secure that whole backbone of the API system? Now, why is it a problem and whose problem is it, right? Because developers, they need more support to understand security. There's no secret there. A lot of the developers, they often don't know about some of these vulnerabilities. Broken access control is now the new #1. And I think the APIs are just opening up the attack surface, and very small problems or very small configuration issues can lead to some very big problems inside the API system. We've seen an example of that, I think, last year. There was a company in the US called Experian, and they were a credit score check system. So basically, they have a record of every single Australian citizen and keep their credit score in basically a system. Now what they did at Experian, they built an API for their partners to connect to. So they exposed something called the Experian Connect API, and they basically said to their partners, hey, if you ever want to do a credit check on one of your customers, you can call our API, give us some data, and we'll let you know what the score is of that person. Now the mistake they basically made is that the only level of authentication they did on that API was saying, well, give me the name of the user that you want to check, give me their address, and give me their birth date. And that was all. There was nothing else needed. So you can immediately imagine that it is not that difficult today to find out my name, where I live, and what my birthday is with all the social media stuff. So that allowed anyone to start writing scrapers to basically empty that whole database through the API and find out the credit score of every single American citizen. So it is small problems like that that can lead to really big problems or big data breaches. Now, in an ideal world, all the security people in this room here would say, well, when developers are building software, when they are designing it, when they are building it, when they are deploying it, every step of that cycle, security needs to be part of it. Like that's all what we promote, that's all what we think that needs to happen. But in a real world, that actually never happens. It is very infrequent that you can see something build out like that where every developer really cares about security. So what we do at Secure Code Warrior every year is we go out with a survey, and we want to know not what security people like us think about secure development, but we want to know what does the developer think about security, because they're the ones that can solve this. I was speaking with somebody 5 minutes ago and said, well, I'm one app, like half of my job is AppSec, and I've got like 70 to 100 developers to take care of. Like it's very hard to do that. On average, I think in the banking world, there is one AppSec guy for about 500 developers. There's no way on how you can scale doing that all on your own. So making developers part of this solution is really important, and to really get their buy-in. So as I said, we did a survey. We used Evans Data, which is a research company, to go out to 1,200 developers, and we wanted to know what they think about security. Now, from those 1,200 developers, there were about 50% that were professional developers doing day in, day out, and then we have about 30% which were doing development and also managing software engineering teams. So we went out, The demographics was most of them were North America. But yeah, we asked them, the first question we basically asked them is saying, hey, do you think that you're leaving code that is vulnerable? Like, do you know that you're leaving vulnerabilities in your code? And 50% came back and said, yeah, we're actually very aware that most of the code we write has problems in it. We know that. They're very, very honest about it. There's 33% that said not a single line of code is vulnerable in our company, which is hard to believe. But then there's also 19% that think, well, it depends on what project I'm working. With some I will leave problems in, with some I won't. Now, the second question we asked them is said, well, what type of problems do you still think exist in your code? And of course, what you can see, the most one that is well known today, it's the usage of libraries of frameworks that they haven't built themselves, right? The usage of open source modules or of basically software composition analysis. And I think there's a lot of focus on the market on that at the moment. But also things around privilege escalation, unencrypted data, backdoor credentials. So you obviously see that the developer starts to understand what are some of the weaknesses we're leaving behind. Now the question we need to ask ourselves, why is that so? With all the tools we have today, with all the expertise we have today, how is it possible that we still have developers writing vulnerable code? So we basically asked them that code as well, like, why do you think those vulnerabilities are still in your code? And you can see that the majority of their responses was basically that our priority is to build code as fast, or build features as fast as possible and get them out. And we need to meet the deadline, and for that, we're going to sacrifice everything else. So we actually don't have time to build secure code. Now, this is not a developer's problem. Like, the developer cannot solve this. They can't say, well, they don't prioritize these things. So that comes down, in my opinion, to product managers, to CIOs, to say, well, building things is important, but we need to build it in a secure way and not always sacrifice everything for speed. There's a few other statistics that came out and saying, well, we don't really know what makes our code vulnerable, or every single line of code or every code has vulnerabilities. And of course, they might sometimes lack the knowledge to do that as well. Now, about 76% of the developers think that, well, if we actually would train and educate ourselves on software problems, it would help us a lot when we're actually building the code. The problem is that they're time poor. They don't get the time. They don't get the time to build things securely, but they also don't get the time to learn about these problems in a way. It's a lack of time that is preventing them from integrating security into their software development lifecycle. Now, if you want to read more, we have the whole research out there. It's about 50 pages with a whole bunch of stats, but it will give you insight in what is the developer actually thinking in security. Many developers, they think that secure code means that they just need to scan the code and that's it. They think that scanners will solve all the problem. In my opinion, it's not. Like, it's. I often make the comparison with what's the difference between software engineering, which is a profession which is 50 years, 6 years old, with the difference with civil engineering, which is a profession which is roughly 2,000 years old, right? Now, if you look at civil engineering, building bridges, building houses, when we first started doing that 2,000, 3,000 years ago, the first bridges we built, they collapsed. The first houses we built, they've collapsed. Why? Because nobody cared back then at building a secure bridge. They just want to have a place to go from A to B and build it as quickly as possible so they could do trade and so on. Software engineering is in a very similar state today, right? We get people from the university. We basically ask them, what you need to do is build a mobile app as quickly as possible and get it in the hands of the users, not realizing that what are the risks we're running by doing that. So in my opinion, software engineering will need to go through a transition to say, well, it needs to be treated the same as civil engineering, the same as doctors and nurses, where patient safety is one of the core things that you understand, while in software development, it doesn't happen today. Anyone that can code can get a job and can write software for critical infrastructure, for critical applications, because nobody is asking the questions to them. Now, what happens if you do find developers that know security? Like what are the results? Are we seeing any improvements on this? Now we actually did a test with one of our customers. They had about 5,000 developers around the globe, and their goal was to get rid of the most common problems. Like they had scanners, they had security testing, they had bug bounties, but what they were seeing is not as different as what you guys are seeing, is that those same weaknesses are coming back with every scan, with every test. You see the same like 5 weaknesses coming back every single time. These are pieces of code that have been written by different developers in the organization, but it keeps coming back. Now, how do we solve that problem? Because all of that recurrent vulnerabilities, it's causing us, it's losing time, it's losing speed, and it's losing efficiency. So what they did was, in step 1, they said, well, we're going to build a certification pathway for developers. That means that we're going to offer the developers a pathway to start at 0, where they are now, and we want to say, hey, we will build this belting system where you can get a white belt, you can get an orange belt, you can get a black belt. In this case, it was white, yellow, and orange. So they had a belting system there, and they said, well, the white belt is the basic security 101, which means you need to understand about the 3 most common weaknesses that we have in the organization. And then the yellow belts are the OWASP top 10, and the orange belts are like the AppSec champions, the ones that are really the experts. Now, what they've done is they've pushed that whole organization through that system. Now you can see that there were 30% or 50% of the developers, they basically said, well, I don't want to do certification, I'm not interested, I don't have time. Their choice. They had about 70% that went through the first level white belt, and then they had a few that kind of went on and said, well, I'm actually really interested in security and secure coding. I basically want to learn more. So that was one initiative they did. The second initiative they did is they started running these things in a way where it's fun, it's gamified, it's events, it's capture the flags, whatever you want to call it. But they did it not as like a structured learning, but they did it in a way where it's engaging and interesting for their developers. So we had about 3,000 developers joining these events over 3 years. And in total, we measured how much time have those 5,000 developers spent on training. And in total, I think it was about 13 years. Now, the consequences are that company that's writing software today, that we're seeing those hundreds of injection attacks and cross-site scripting attacks, they don't see any of that anymore today. Why? Because they've managed to put a baseline out there that has lifted every single developer in the organization, not making them experts, but just making sure that they don't know about, or that they know how to avoid the basic SQL injection, knowing how to encrypt and store data, and basically knowing how to get rid of cross-site scripting. And they've eliminated that across the whole organization using that. So I do believe if you help and if you give knowledge and skills to a developer, I do genuinely believe that you can have an impact on the efficiency and the speed of software development. Now, we had another test where we asked the customer, well, what actually happened when you saw that all your developers were going through skills and learning about these things? What did you see happen with the number of vulnerabilities that were tracked in your systems? Now, one of the customers actually said, well, to be honest, we saw them going up. We used to have like 1,000 security bugs being logged into Jira or into our ticketing system. We've basically pushed everyone through the certification pathway, and we suddenly saw an increase, like 1,500 to 2,000. And we were wondering, well, how is that possible? You've basically pushed everyone through a skills program, and now you're seeing more and more weaknesses coming back rather than less. So we dug through the data, and we actually saw that in the past, those 1,000 vulnerabilities were being logged by scanners and by security teams. The 1,500 after the whole test, the majority of them were being logged by the developers themselves. That basically said, well, I know this is a problem in his code, and they were doing peer reviews. They were going to their legacy code, and they basically demonstrated that they now have the skills and knowledge to be able to find those problems themselves without that single person in AppSec running these scanners and so on. So again, for us, that was a proof point that you can build security into the DNA and actually have an effect on the number of vulnerabilities that you see. Now, I want to close off with some of the things that we've seen work, or what I would ask people to do, is that asking yourself, is shipping vulnerable code, is that worth sticking to deadlines, or should we actually be more lenient and say, well, security is as important as delivery, and we need to make sure we give people the time to train and to learn. So first of all, I would say for API security, keep an eye on it, because it's going to get worse, and there are going to be more and more breaches that are being caused by insecure and bad APIs. So give the developers the time to get hands-on with some of these vulnerabilities and learn how to avoid them. The second one is around clear responsibilities. Now, very often developers think that AppSec is responsible for security. I think that is wrong. AppSec is there to support, AppSec is there to help the developers, but we need to make sure that it's the builders, the ones that are actually building the code, that they understand that it's part of their responsibility to build things in a secure way. Just like a civil engineer, just like a doctor, just like every other profession, that security is them that can help. And then the last one, to me, it's the time you're spending now up front to fix vulnerabilities is basically, if you give the developers more time to care about their code, it is going to ultimately end up in faster software development that is more secure. So my key call out is that we need to make our developers superheroes. They need to feel like superheroes, and they need to feel that they are part of this problem. Good, I hope you enjoyed the talk. Thank you very much for showing up after lunch. And see you next year.
Thank you very much, Pieter Danhieux. We've got one question coming through online, so please keep them coming. Here we go, some more now. What role can a developer play if using an API that is not developed by them, i.e. they are integrating an API? How do they contribute to secure development?
Yeah, that's of course, it's a very similar problem that you have with open source packages. You don't control the code, you don't control the API. What if you find a problem in that API? I think the only thing you can do as a developer or as a security person is to make sure that you look up, well, who owns the API? Is it an external organization? Is it internal? And figure out, do they have a security contact? Do they have a bug bounty program? And notify these people about the API. And unfortunately, I think that's the only thing we can do. We have to somewhere rely upon the whole supply chain of APIs and supply chain of open source packages until we kind of figure out how to do that in a more proper and structured way.
Cool, thank you. There's a good question coming through around engaging developers who just don't care about security as well. Do you know any good strategies or stories that have helped?
Well, I've seen things that work really bad, and I've seen things that work really well. I think the worst thing you can do is force developers into courses or training or learning that they don't want to do. Like, that's a waste of their time, it's a waste of your resource, and a waste, and so on. What I have seen working well is trying to engage them and their colleagues on building this superhero image about the developers. We often give out t-shirts or hoodies to people that have demonstrated capabilities in secure development. Like when one of the developers lodges a security issue and fixes it quickly, we will reward them with something that is visible to their colleagues. Could be badges, could be t-shirts, could be stickers, could be just some kind of a visibility to show the rest of the organization what that developer has done. We appreciate that because they're helping us to secure our data. And I think I've seen companies like PayPal, they have their own reward system internally. For anything that you could do good in the organization, you can get a reward. They've started linking their secure development programs with that reward system. If a certain developer gets to a certain, or follows a certain course or does a certain thing, they basically get rewards. The stick approach often doesn't work, but the rewarding approach and making them engaging and basically showing that they're heroes often works way better than basically going to them with a pen test report where everything is red and saying, I need you to drop everything now and fix these issues. And I think that's one of the problems that we have been having as an industry is that, and I've been at fault of that, is in the past when developers got confronted with security, it was usually because we found a hole that needs to be fixed immediately and the security team came in with a red report, and that's kind of how this whole industry has started for the last 20 years, and we need to change that. That's why I think rewarding developers and making them part of the solution and the problem works way better than going with the stick.
Absolutely, thank you. And on that topic around gamifying and competition, any difference between Australian and Belgium devs or organizations around secure coding?
That was my microphone gone. That's a difficult question. Any difference? There are geographic differences between developers and what they care about. Like I've noticed, not specifically about Belgium and Australian developers, but I've noticed, for example, that there's a lot of people in Southeast Asia that care a lot about the certification aspect of their own credentials, like where they get a reward and they get a piece of paper that shows that they've been part of something. The gamification aspects in Southeast Asia are very often less accepted than in Australia. Like in Australia and the Anglo-Saxon countries, like gamification is like, it's a fun way on how to do it. They usually don't care about the certification, but the developers in Southeast Asia, they care more about getting the piece of paper and a certificate afterwards, rather than I think the gamification, which might be seen as this is not something serious. So didn't really answer the question on Belgium versus Australia, but I hope that gives you an idea that developers in countries are different. They're not all the same.
Yeah, and different cultures as well, right? So there was one question just about sharing the slides. Are you comfortable or okay with people reaching out about sharing the slides?
Sure. I don't know if AusCERT does that or whatever, but if not, I think my email address is on there, and happy to share slides if needed.
Excellent, thank you. That's the last one I saw online. Are there any questions within the room here? Oh, one here. Get my steps up, this is great.
Hey, really interesting talk. I guess around the measuring is something, certainly as a veteran of pen testing, you're almost penalized as an organization by paying attention, and it kind of draws on your comment about, you know, after the training went through, there were more bugs, and then there's a perception that that's a failure, whereas it's actually a recognition that people are noticing the issues. So how do you overcome that cultural issue of the more you pay attention, the more you know there is stuff wrong, and that almost makes you look worse in the short term?
Yeah, there's usually two metrics of success that we're looking for. One is, well, do you see the number of vulnerabilities going down, which is not always the case, sometimes it will go up. But the second one is, what is the time to fix a security weakness? Now, in an environment where nobody knows what, let's say, a cross-site scripting attack is, right? The time to fix can take weeks or months even trying to get that bug fixed, right? But somebody that knows what it is and knows how to fix it and knows the coding pattern, how to get away with that flaw, can fix that within 1 or 2 seconds or 1 or 2 hours. And that means the time to fix, you can find it into ticketing systems like Jira and GitHub Issues. By using that metrics, you can actually show, hey, our developers are now, maybe they're not writing less bugs because we can notice the number of things going up, but we can actually fix them much faster and respond to these things and basically keep the speed of software development high. So that's usually how we try to position that.
Great question. Thanks, Glenn. Were there any other questions in the room? I have one final one. Do you want to hear a bad joke about programming?
Yes.
All right. And it's on point, on theme, rather. Why does Yoda's code always crash? Because there is no try. Can we give a warm round of applause for Mr. Pieter?
Good one. Thank you, everyone.
He's gotta get out of his head and go inside his heart.